Hey everybody, sorry for the late post, but finally made the notes. So, some good news. We're in chapter 6.1 now, and in this section there's only going to be three sections: 6.1, 6.2, and 6.3. And then after that, we're having our exam. So, why is it good news? Because in this section, we're working on solving equations. And since both sides of an equation are assumed to be equal, we can now do everything that we couldn't do in chapter 5. So now it's legal for me to add a number to both sides, to subtract a number from both sides, to multiply a number to both sides, to divide a number by both sides, to square, to square root, to raise both sides to a power, or to log both sides. So before I couldn't do it because when we were doing proofs, the sides weren't assumed to be equal. That's what you were trying to prove. But now in these equations, they're assuming they're equal, so now we can do all the stuff we couldn't do before. And I just wanted to put a cat there. Rawr. Anyway, so let's look at our first example. It says solve 2 sine of x minus 1 equals 0 for x. So I'm just going to get my equation and solve it like normal. I add 1 to both sides. All right, so that cancels that out. So there we go. I have 2 sine of x equals 1. And then the next step would be to divide both sides by 2. All right, so now we have sine of x is equal to 1/2. Okay, so the biggest sin you could possibly ever commit would be to do this. And I've seen people do it. They say, oh, divide by sine, divide by sine. And then I cry on the inside because you can't do that. It's not sine times x. It's sine of x. Okay, the sine and the x can't be separated. It's a function. So please, 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 please do not make that mistake. I will destroy you. Instead, the algebra stops here. Because there's nothing more we can do algebraically. Now all we got to do is we have to figure out what values of x does sine of x equal 1/2. And so here, again, the little table that we remember to make. So sine, our angles are 0, 30, 45, 60, 90. The radian equivalents are, I'm going to put them up here in the blue area. 0, pi over 6, pi over 4, pi over 3, and pi over 2. And then my angles for sine are just, not my angles, but the values are 0, 1/2, square root of 2 over 2, square root of 3 over 2, 1, and I do them in reverse for cosine. So this is a good thing to write when you're making a test. This should be the first thing you write on the test, or whenever you're taking any kind of exam, just so you don't make any silly mistakes. So I noticed that sine of x equals positive 1/2. It's a positive 1/2. And I know for sine, we have plus, plus, minus, minus. So for sine of x to equal positive 1/2, that's going to be, and I'll erase this in a bit, but that's right there. Sine of x, when sine of x is 1/2, the angle involved is either 30 degrees or pi over 6 radians. So 30 degrees, I'm kind of exaggerating it a bit so I can fit it. Or if you want to think of it as pi over 6. Depends on the problem that you're working on. But sine's positive in 2 locations. So not just there, but over here too. And again, that's also pi over 6 radians. So this table that we made isn't really the actual value. These are my reference angles. And no, I already know when sine, cosine, and tangent are positive or negative. So I know my reference angles, and now I can calculate the values. So the two angles I'm looking for are 30 degrees, and the other one is over here. And notice that that's just 180 minus 30. So if you're looking at the two angles, my two solutions are my actual answers. Let's do degrees first, and then I'll do radians. So the first answer is just 30 degrees. X equals 30 degrees. And then the other answer is x equals, and then this one is 180 minus 30, or 150 degrees. Okay? Now, if you were answering them in radians, you would say x is equal to pi over 6. And then we have a full pi. Remember that from this is 0 pi. Here, this is pi. So if you take pi and you subtract and you go backwards, pi over 6, you end up with 5 pi over 6. So in degrees, 30, 150. If it's in actual radians, pi over 6, 5 pi over 6. But then not only that, I can go around the circle as many times as I want. So even though I have 30 degrees, I can go around another full rotation. I can go another full rotation. I can go another full rotation. So we have to add to it. It's really 30 plus a full rotation, 360 degrees K. 150 plus 360 degrees K. If you're doing the pi route, it's pi plus, and a full rotation for pi, or a full rotation for radians, is 2 pi. And so those are the answers. Depending on if they want radians or degrees, those are the answers you're going to give. Oop, a little too small. All right, so notice the algebra itself is easy. All I did was add 1 divided by 2. The rest is knowing your table, or being able to write your table out and refer to it, and knowing where sine, cosine, and tangent are positive or negative. That's going to be really, really important in this section, because all the answers in your table are reference angles. So they're from the x-axis, and they either go up or down from the x-axis. And based on the answers, you know you have to give starting at 0 to get to the first one is 30. Starting at 0 to get to the second one is 150 degrees. Anyway, so that's the first one. Let's look at our... Oh, and on the homework, they make a big deal about giving generic answers and then giving answers just between 0 and 360. So in one rotation. The smallest positive solution. And so if you want just the smallest positive solutions, that's going to be 30 degrees and 150 degrees. So on your homework, they separate it into 2 questions. The first question wants the all answers, where you have to add in the 360k or the 2 pi k. And then the second part is going to want just the smallest, in one rotation, what are the smallest answers? In this case, just 30 and 150. Or in radians, you would write pi over 6 and 5 pi over 6. All right. So now let's go to the next one. The next one says solve 2 cosine x minus 3 equals 0. And so this one's same as before. I add the 3 to the other side, and then I divide by 2. But notice that 3 halves is 1.5. Okay? But if I'm dealing with cosine, this is a really bad cosine. Okay? The cosine only goes between 1 and -1, meaning that the range of cosine is -1 to 1. So 1.5 is not attainable, not in the range. So cosine of x equal 1/2 never happens. In this case, we would just say no solution. Okay. Now on an exam or something, you can't just say no solution. You would have to explain to me why. You would say cosine of x is 1/2. Cosine can never equal 1/2. Or sorry, 1.5. Cosine can never equal 1.5. So therefore, no solution. Now in Desmos, I can show you the same thing. At cosine of x, and then y equals 3/2. So notice that the two solutions never ever meet. Sad times. All right, excuse me. So let's go to the next page. Got 3 more examples. These get a little bit harder, but they're pretty much the same idea. All I'm going to do now is I'm going to solve for the cosine equation. So this part right here cannot be separated. Cosine and what it's attached to has to stay together. So this is what I'm going to solve for, which means everything else I'm going to move around. So I'm going to add the square root of 2 to the other side. So equals square root of 2. And then I'm going to divide everything by -2. So I have cosine of a minus 25 degrees equals, and it's bad manners to leave the negative on the bottom like that. So I'm just going to say negative square root of 2 over 2. Okay? So for now, I'm going to ignore this a minus 25. I'm just going to say cosine of theta equals negative square root of 2. You know what? Not even theta, because that might get confusing. I'm just going to say cosine of equals negative square root of 2 over 2. Okay? Well, when does that happen? Well, for cosine, I know cosine is positive and positive on the right, negative and negative on the left. And if I go to my table, square root of 2 over 2 is right here, which means it's at 45 degrees or pi over 4. In this problem, they're looking for degrees, so I'm going to go with just 45 degrees. Okay, but it's negative. So what I'm looking for, my reference angle, this little, I guess I can call it that, theta hat. Theta hat is equal to 45 degrees. Remember, theta hat is the symbol we used way back in chapter 2. Chapter 3? No, chapter 3 for reference angle. But it's negative. So where is my cosine negative? Cosine is negative in quadrants 2 and 3. So I'm going to put 45 degrees here and 45 degrees there. So those are my two reference angles. Now I got to figure out, okay, well, what are the actual angle? Well, the actual angle starts at 0 degrees. And to go from here to here, and again, you can use your calculator if you want. Let me bring it up. That's just 180 degrees minus 45, and 180 degrees plus 45. So this is 135 degrees, whereas the one below it, going down there, is 225 degrees. All right? So as far as my solution goes, I think I'm going to run out there, solutions. All right? My answer is, remember that the inside was a minus 25. So the inside is equal to 135 degrees. And then again, it can go as many rotations as it wants, 360K. Or it's a minus 25 degrees. And then the other answer, which was 225 plus 360K. Okay? So what we're doing is whatever the inside is, that's what's equal to your angle. And then from there, the algebra can resume. So now we can just do some algebra. Let me separate these a bit. And it's the easiest algebra ever. All you do is you just add 25 to each side. So my value for A is 135 plus 25. And my brain is dead right now, so I'm going to be lame. If I could. 160. So 160 degrees plus 360K is one answer. And then the other answer is just 225 plus 25. So 250. So that's all you do if you have stuff going on the inside. All right? So those are your solutions. Okay? On your homework, you would just write them out and you would separate them by a comma. Now, if it's asking for the in one rotation, solutions between 0 and the variables a, you would just say, if they're looking just for those answers, you would just say 160 degrees, comma, 250 degrees. So again, the homework's going to ask you both. It asks you for every solution possible, which is these two formulas, and then it asks you just for, basically you drop the 360K from each of them, 160 to 250. All right, let's go to the next one. Solve 7 minus 8 sine x plus 3 equals 10, where x is in radians. So now instead of degrees, we're going to switch to radians. So first, again, I'm just going to solve for this guy. So the first thing I can do is I can subtract 7 from both sides. So those 7s cancel. Negative 8 sine of x plus 3 equals 3. And then I can divide by negative 8. And it's bad manners to have a negative in the denominator. So this is just negative 3/8. All right? Now this isn't a special answer like the other two were. Basically, if I go to my table, negative 3/8 isn't there. So if it's not a happy answer, or an answer that we're used to seeing, what we can do is, for now, I'm going to pretend that x plus 3 is just a reference angle. Okay, so we're going to hide this for now, but when I get my answer, when I get my two answers over here, then I'm going to bring the x plus 3 back. But so now, for now, it's just the inside. And so I'm going to do inverse sine. My reference angle is inverse sine of negative 3/8. Okay? And really, you don't really need a positive or negative. I already know what quadrants it's going to be in. Notice here sine is negative. This is for sine. So I know my answer is going to be in these two regions down here. But anyway, I go to my calculator. I do inverse sine. Well, first, we have to be in radians. So mode, notice that would have been bad. It's in degrees. I need to switch to radians. So second sine, negative 3/8. Oop. All right, and that's about equal to negative 0.38. Here we're just estimating. All right. Well, since it's negative, and this is a reference angle, that means that I'm over here, always from the x-axis, and reference angles, technically you label them as positive, because they're not actually a measurement. And then the other one's right here. It's also 0.38. So those are my two solutions. Now I got starting at 0, I got to figure out what they are. So the first one is this angle. Remember, here's 0, here's pi. So this first angle is pi plus 0, and I'm just using my approximation, 0.38. So that's about 3.52. Okay, so my solutions. This is where the x plus 3 comes back. And we get 3.52. Okay, plus 2 pi k. Okay, remember 2 pi is a full rotation, and the answer is basically any time you rotate and you get this angle. And from there I can just subtract 3. And so x is equal to 0.52 plus 2 pi k. All right, and then we go to the next one, which is this angle. Oh, sorry. Start at 0, not start at the angle. And to get this angle, notice that this is 0, or if we do a full rotation, this becomes 2 pi. So this is a full 2 pi minus 0.38. And that's 5.9. So the other solution is x plus 3, the inside of the sine, is equal to 5.9 plus 2 pi k, and then you just subtract 3 from both sides. So 5.9 minus 3, 4, 3, 2.9 plus 2 pi k. And so those are your solutions. And just to show you in Desmos that this is the correct solution, I'm going to go ahead and work this out. So on Desmos, this question was 7 minus 8 sine of x plus 3. Make sure projector mode, turn off the grid. It's in radians, that's good. Equals 10. So here's that, and here's 10. And notice all the times it crosses. There's 2 times it crosses, and they're close to each other. And then there's a gap. and then they're close to each other again, and then there's a gap. But let me just look at the first two positive solutions. 0.526, 0.289. And since I rounded to two decimal places, I put 0.52. Did I not? Oh, I guess I didn't round correctly. 0.526. Oh, because I did 0.38. I didn't put the whole thing. But anyway, 0.52 and 2.9. So you go to Desmos and you see pretty much the same thing. Right? The reason why it's off a little bit is because when I did my number, I did pi plus 0. And I just did 0.38. I didn't put the actual exact answer. But anyway, so those are your two answers. Notice they're close together, and then there's a gap. They're close together, and then there's a gap. Well, if I go back over here, notice that these first two parts, these are close together, and then there's a larger gap. They're close together, a larger gap. Close together, a larger gap. Anyway, let's go to this last one on this page. So it says solve 3 tangent theta minus 2 equals 7 tangent theta minus 1. So for this problem, and this is in degrees. So when it's in degrees, be sure if you're going to use your calculator, you go to mode and you set it to degrees, or else you're going to be sad. All right. So we're going to be solving for tangent theta. And notice that there's 2 tangent thetas, and so these are pretty much like terms. What I can do is I can say minus 3 tangent theta, minus 3 tangent theta, and since they're like terms, they can combine. So I have negative 2 equals 4 tangent theta minus 1. Then I can add 1 to each side. This is the algebra part. Negative 1 equals 4 tangent theta, and then I can divide by 4. And so now I have my angle. I have tangent theta is equal to negative 1/4. Okay, this is not a special angle, so I'm just going to use inverse tangent. So inverse tangent of negative 1/4, and that's negative 14.0304 degrees. So my reference angle, remember the inverse function only gives you the reference angle. It doesn't give you the actual angles. So inverse tangent, or if you want, you can say arctangent. Why is it not erasing? That's weird. There we go. So I can say arctan if I wanted to. Anyway, when I do it, I'm going to approximate negative 14.04. And so that means that my answer, if we're dealing with tangent is positive, negative, positive, negative. And so the angles I'm looking for are negative 14.04. So we go down this way. And the other one is 14.04 in the other direction. Okay? Now, tangent has the property that these two answers are 180 degrees apart. You know what? I'll show you later. But for now, let's just pretend like we've been doing all the others. All right. So my solution is going to be, here's my first angle, and that's just going to be 180 degrees minus the answer that I just got. Well, it is negative, so hold on. Let me multiply my answer times negative 1 to make it positive. Reference angles are positive. Okay, so I do 180 degrees minus that number. and that's 165.94. So that's that angle. Okay, so my answer here, my solution, is theta is equal to 165.94 degrees plus 360K. And then the other answer is almost a full rotation, but it stopped short by 14.04 degrees. And so that's going to be a full rotation minus 14. I'm just going to type in the whole thing. 0, 3, 6, 2, 4, 3, 4, 7. And so that's 345.96. Okay? And so that's 345.96 degrees plus 360K. Right? But when it comes to tangent, tangent has a special property. It's that these answers happen to be exactly 180 degrees apart. So if I go from one answer to the other answer, it's just 180 degrees. So notice that 165.94 plus 180 is my other one, 345. It's off by a little bit because I rounded. But anyway, and then I add another 180. See, that's the bad thing about rounding. And then I add another 980, another 180. And so I can actually combine these two solutions into just one solution. What you do is you pick the very first one, and instead of saying 360K, you say 180K, because the answers are 180 degrees apart. But remember, this is something that only works for tangent. All right. Good stuff? Sure is, Gilbert. All right. So the next questions I want you to do on your own. Question 6, question 7, and question 8. Notice question 8 has cosecant. Let's see if you can figure that out. Now I want to go on to question 9, and we're just going to do 3 more, and then we're done. All right. So question 9, these questions are a little different. Notice I have 2 things, because here, you look at this problem and they say solve, but you have to think of these as variables. You have eh. So if you're looking at these as terms, notice that they both have tangent in common. Excuse me. Which means that I can factor it out. I can take the tangent theta out, and there's an invisible 1 here. Kind of looks weird written right there. But there's always 1 times tangent, so if the tangent's gone, a 1 is left over. And if the tangent's gone, a 2 cosine theta is left over. So this is another way how we can solve these problems. Each one becomes its own equation. So I have tangent theta equals 0, and 1 plus 2 cosine theta equals 0. This one I can already kind of look at for a bit. This other one I got to solve by subtracting the 1 and dividing by 2. So if I do that, I get negative half. Okay? And so these are the 2 that I'm looking at. One is a tangent, the other is cosine. I know tangent is positive, negative, positive, negative. Cosine is positive on the right, negative on the left. Okay, so let's do the cosine first. Cosine is negative half. Well, this is a special angle. And here, well, I did it in both, but we go back to the little table that we made at the very beginning. And so cosine is a half at 60 degrees or pi over 3. So going back way over here. So, and it's negative. So here my reference angle is going to be 60 degrees. But because it's negative, I know my 60 degrees has to be over here. Okay? And you can think of it as pi over 3 if you want. So if that's 60 degrees, then my two angles are going to be starting here. This first one's going to be 120. And the longer one is going to be, what color should I use? I'll use the blue. And so that angle is 120 plus 260, so another 120. So that ends up being 240. So this angle is 240 degrees. So my solutions, I'll put them underneath. It's going to be 120 degrees plus 360K, or it's going to be 240 degrees plus 360K. If you were doing it in radians, so this is the degree solutions. If you're doing it in radians, it would be 120 degrees is 2 pi over 3. I'll write them next to each other. So this solution is the same thing as 2 pi over 3 plus 2 pi k, whereas the other one is a full pi plus another pi over 3. That's 4 pi over 3 plus 2 pi k. Right, so all I did was here's 0, here's pi. Pi minus pi over 3 is 2 pi over 3. Pi plus pi over 3 is 4 pi over 3. Anyway, so those are those answers. Now we can go to the tangent. And when does tangent equal 0? Well, tangent is sine theta over cosine theta. And so if you multiply both sides by cosine, you don't have to do this, by the way, but if you don't have your sines and cosines memorized, this is the same thing as sine of theta equals 0. Tangent equals 0 and sine equals 0 share the same solutions. So when does sine equal 0? Well, sine equals 0 at 0 degrees and 180 degrees. Okay? So the answer really, there's only one answer. It's just 0 degrees plus 360 plus 180K. Because it's 0, 180. Next one. Eh, eh, eh. And if you wanted to write that in radians, you would say 0 plus, instead of 2 pi k, it's just pi k. There you go. Okay. So your answer in radians, let's say you wanted to write the final answer, all of it up. So in degrees, you would say your solution is 0 plus 180k, comma 120, let's put the little degree symbol. 120 degrees plus 360K. And then 240 degrees plus 360K. If you were doing this in radians, you would say 0 plus pi k, 2 pi over 3 plus 2 pi k, and 4 pi over 3 plus 2 pi k. There is a way to simplify that, but for now, we're not focused on that. I'm just focused on can you get the solutions. And what made this one different from the others is that there was really 2 things to solve instead of 1, because you factored it and each factor was its own separate problem. Okay? Yay! All right, only 2 more left. Let's move on to the next one. So we have 2 sine squared of x plus 3 minus sine of x plus 3 equals 1. All right, so this one is different because, well, first, you can't, there's 2 of the same thing. There's 2 sines. Oh, I'm highlighting. And so what you have to realize here is in this case, it's actually a hidden quadratic. I'm going to subtract the 1 over. And so I have 2 sine squared of x plus 3 minus sine of x plus 3 minus 1 equals 0. So if you wanted to, you could say, let u equal sine of x plus 3. I'm going to replace all of the sine of x plus 3's with a u. So this I'm going to replace with a u, replace with a u. So I end up with 2u squared minus u minus 1 equals 0. Well, this is actually something that can be happily factored. And if you're not a friend of factoring, you can always use your other friend, the quadratic formula. But this one's factorable. It's actually 2u plus 1, u minus 1. And then each of these is its own thing. So this is 2u plus 1 equals 0. U minus 1 equals 0. So u is negative half. U is equal to 1. But now I replace u with what it is. U is sine of x plus 3. So sine of x plus 3 is negative half. Sine of x plus 3 equals 1. So that's what makes this problem different. Here are my 2 separate problems to solve. The algebra is pretty much done. Now all that's left is the trig. So let's go ahead and solve it. Here I have 2 sines. So I'm going to make each of these little tables here a thing for sine. So this is going to be for sine. This is for sine. The first one, we have sine is negative half. Okay? Sine is positive on top, negative on the bottom. And if I go back to my table that I did in the very beginning, because I always forget, when sine is a half, that's right here, the angle is 30 or pi over 6. Where am I? There we are. So here I know that my reference angle is 30 degrees, or if I'm doing radians, pi over 6. Here, when is sine equal to 1? My reference angle for this one is 90 degrees. Or if you're doing radians, pi over 2. So I go ahead and work them out. So when is sine negative half? Well, that means it's negative. I draw my reference angles. There's 30 degrees, or pi over 6. There's 30 degrees, or pi over 6. For the other one, it's 90 degrees. 90 degrees is actually straight up. And so that's just 90 degrees. All right, so let's go ahead and write the answers out. If I start at the beginning, and I go all the way here, that's 180 plus 30. That's 210 degrees. So 210 degrees plus 360K. And then I can start and go to this one. And that's 30 short of a full rotation. Well, 30 short of a full rotation would be 330 degrees. Plus 360K. If you wanted to write their radian counterparts, like if the problem said answer in radians, you could. In radians, remember that this is pi over 6. So it's, and you can use your whole number, it's a full pi, or a full pi, so 1 pi, plus a sixth of a pi. You can math frac that. 7 pi over 6. Okay, plus 2k pi. Or 2 pi k, 2k pi, same thing. And then the other one's 330. Well, that's a full 2 pi minus a sixth. That's 11 pi over 6 plus 2 pi k. Okay, so these are the degree answers. These are the radian answers. I didn't want to clutter the screen, but remember these are pi over 6. Pi over 6. So that's why I was adding or subtracting 1/6. And then I just stick the pi in the answer. This one's a lot easier. The angle from here to here is just straight up 90 degrees, or pi over 2. So this is 90 degrees, and if you want to get to the answer again, you have to add 360. Or you can think of it as pi over 2. Hold on. Let me get the same colors going on. Plus 360k. That's the ugliest 360 I've ever written. Or if you're thinking of it in radians, it's pi over 2 plus 2 pi k. All right. Now the last thing we got to do in order to fix this is, we're not done yet. Remember that this was really x plus 3. There it is. So the inside was x plus 3. So really these answers, they're almost done. Really what's in front of all of them, is an x plus 3. So we're not technically done yet. What you have to do now is subtract 3 from each answer to get your final answer. So my final solutions, I'll put the degrees first and the radians underneath, is if I subtract 3 from all of them. So 210 minus 3, so I can solve for x. Okay, so 210 minus 3 is 207 plus 360k. Then there's the other answer, 330 minus 3. This is 327 plus 360k. And then the answer over here, 90 minus 3 is 87 plus 360k. And then finally we have the answer in radians. And if you wanted to be exact, then you would just stick a -3 on each end. So you would say 7 pi over 6 plus, well, I can say -3 plus 2k pi, like that. It seems kind of silly, but there are numbers that don't mix. So if you want an exact solution, all you can do is just put -3 next to it. And then pi over 2 -3 plus 2 pi k. All right, so that one was a toughie. Okay, it started out being a quadratic in disguise. We factored it. We ended up with two different answers. One is sine of negative. When does sine equal -half? And when does sine equal 1? Well, you write it out. You can use the unit circle to kind of figure out where your answer should be. But don't forget that it really was the inside was x plus 3. So it's really the inside equals all those answers. And so at the very end, you had to subtract 3 from everything. Anyway, I want to show you this in Desmos because the answers that we did get do show up. So I have 2 sine squared x plus 3 minus sine of x plus 3. So it's a cool looking graph. And then I'll say -1. Okay, so we're looking where this equals 0, or where the x-intercepts are. And so this is in radians, so notice that the answers I get are 0.665, 2.76, and 4.857. And so if I go over here, let me highlight them again. So 7 pi over 6 minus 3. .665, bam. 11 pi over 6 minus 3, 2.76. There it is. The last one, pi over 2 minus 3, that one's going to be negative, but if I add, that's going to give me this answer over here. So let me undo this one. It's hidden. It's going to give me this answer over here. So pi over 2 minus 3, negative 1.429. So there you go. Those are your 3 answers. And then to get every other answer, you just add 360 or 2 pi to it. And it gives you every repeating answer after that. And again, if you wanted to convert to degrees, you can. That means I just got to change my x-axis from negative to negative 360 to 360. But you get the same answers. Negative 33, 87, 207. Oh. So I got 87, 207, and 327. There you go. Meh, 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 meh. All right. Anyway, last one, and then we're done. So what makes this last one a little bit harder? It's the same as before, except now, because we're evil, you're actually forced to do the quadratic formula. This is another quadratic problem. 2 sine squared theta. I'm going to subtract the 4 to the other side. So this is like saying 2u squared minus 4u plus 1 equals 0. Now here we're forced to use the quadratic formula. So the quadratic formula, I have a equals 2, b equals -4, and c equals 1. So x, or in this case u, it's not x, is negative b plus or minus the square root of b squared minus 4a times c, all divided by 2a. So 2 times 2 is 4. So I have 4 plus or minus 16 minus 8 is 8. 4 plus or minus 2 square root of 2. And then you divide each of them by 4. And so that gives me 1 plus or minus square root of 2 over 2. Okay, I know I kind of rushed doing that, but it's just the quadratic formula. Something you hopefully remember from your algebra days. And for those that have forgotten the quadratic formula, and then the whole thing divided by 2a. All right, so we're just looking for approximations here. And so the two answers that I get are 1 plus square root of 2 over 2, and 1 minus square root of 2 over 2. Okay, so 1 plus square root of 2 over 2, there's my calculator, is about 1.71. And then 1 minus square root of 2 over 2 is about 0.29. Okay. Now remember what our answer was equal to, though. These aren't, what we were doing is my u was actually equal to sine of theta. So that means that these answers really mean we have sine theta equal 1.71 and sine theta equal 0.29. Well, like we did in the very beginning of the section, sine can't be larger than 1 or smaller than negative 1. So this is no solution. But this one works out. So really I didn't need two separate ones, I just needed one. So for sine, remember it's positive, positive, negative, negative. And in order to figure this out, we have to use the inverse function. So my reference angle is inverse sine of 0. And I guess, hold on, I'll be exact. Inverse sine of 1 minus square root of 2 over 2. Oh, and notice that here, let me switch back to the wrong, wasn't degrees. We switch back to radians. So when is sine equal to 0.29? Should have worked for the other way. Hold on. Did I forget to do inverse? I think that's what would have happened. Yeah, okay, I just forgot to do the inverse, my bad. Okay, so I'm gonna do this one in degrees just because the numbers are bigger. So 16.86 and then 16.86 in this direction. Okay, so that means my solution so my actual solutions, and what can I do? Where can I write them? So my actual solution is going to be 16.86 plus 360K. And then the other one is going to be this angle right here, which is 180 minus 16.86. So 180 minus that answer, 163.14 plus 360K. And so that's your solution if you have it in degrees. In radians, it's the same thing, except that this is 0.29. So I guess I'll do it in radians. If you wanted to do the answer in radians, it'd be 0.29 plus 2 pi k. And then the other answer would be pi minus the 0.29. 422 68377. And so it'd be 2.84 plus 2 pi k. All right. Now, again, if both answers were between -1 and 1, then I would have to do a whole nother picture, which would possibly have 2 more solutions. So the hardest this could be is if you have 2 different solutions and each of them have their own separate answers, in which case there would be 4 possible solutions. And yeah. Anyway, when you're doing the homework, it always asks you for the generic solution, and then it asks you for a specific solution, in which case just drop the 360K and just give the answers between 0 and 360, or 0 and 2 pi. Anyway, do the rest on your own. I'm going to post a video of this later tonight, but right now I got to go clean the kitty's litter because it's stinky up in here. All right, have a good day. Take care of yourself.